Okay, today we're going to talk about what happens when you have variables on both sides of your equal sign, right? If you look at letter A, I have variables over here and I have variables over here. Okay, I only want to have variables on one side of my equal sign, so what I'm going to have to do is eliminate them using inverse operations from one side. And I'm going to show you that it doesn't matter which side you eliminate them from, okay? You're going to end up with the same answer. So I'm going to rewrite this over here in this pink color. So 7 minus 8x equals 4x minus 17. Okay? So what we're going to do is I'm going to say that I don't want to have my variables on the right. Okay? This is just not right. All the variables should be over here. So to get rid of this 4x, I'm going to subtract it. And remember, whatever I do to one side, I have to do to the other. So now I have 7 minus 12x equals negative 17. Okay? And now it should just look like a regular two-step equation. I'm going to subtract 7 from both sides. So I get negative 12x equals negative 24. Then I'm going to divide both sides by negative 12. Negative 24 divided by negative 12 gives me x is positive 2. Okay, but watch what happens. Let's see if I can find another color. I'm going to do this. Okay, we're going to solve the exact same equation. 7 minus 8x equals 4x minus 17. Okay, but this time I'm going to get rid of the variables that are on the left side. Okay, so in this case, I'm like, well, I don't want this subtracting 8x. So I'm going to add 8x to both sides. So what that leaves me with is 7 equals 12x minus 17, right? I got rid of this subtracting 8x by adding 8x to both sides. So now I'm like, okay, well, here's my x. I want to undo that subtraction using addition. So, oh, this is all crooked. Sorry. So 7 plus 17 is 24 equals 12x. You can probably see what's happening at this point, right? We're going to divide both sides by 12 to cancel that out. And I'm going to end up with 2 equals x. It's the exact same answer, right? Exactly the same. As long as you're eliminating the variable from one side and performing the same operation on both sides of the equal sign, you really can't go wrong. Okay, let's look at letter B. What in the world? Okay, we have this parentheses and a fraction, so we're going to go ahead and use the distributive property. Okay, I'm not going to mess with anything over here on the left-hand side. Okay, I'm going to leave that as 9x minus 5. Okay, but now I'm going to take this 1/4 and I'm going to distribute it to everything inside my parentheses. 1/4 of 16x is 4x because 16 over 4 is 4. And then 1/4 of 60 is 15. Okay, so I took my 1/4 and I distributed it to everything inside my parentheses. So now I'm back to kind of where I was in the previous problem. I have x's over here and x's over here. So I want to get rid of the x's over here. So if I were to subtract 4x, what's 4x minus 4x? Is that no x's? Yes, which is what I want. So I'm going to do that to both sides. Sometimes people get confused when there's not an operation symbol in front, but just think about it, right? If you have 4, how do you undo that? Well, you take 4 away, right? If I added 4, if I made this a plus, okay, which I'm not going to, but if I made that a plus, 4 plus 4 would be 8x. Did that get rid of anything over here? No. Okay, so 9x minus 4x is 5x minus 5 equals 15. So now it's a regular two-step equation. I'm gonna add 5 to both sides to get 5x equals 20. Okay, and then I'm gonna come over here because I'm trying to show all of my steps. I'm gonna divide both sides by 5 When I divide that by 5, I get x equals 4. Let's look at letter C. So again, I have distributive property over here on the right. I'm not going to mess with anything on the left. 3 minus 4a equals 5 times a is 5a minus 5 times 3 is 15. Okay, I do not want variables on both sides, so it really doesn't matter which side you get rid of them on, right? I'm going to go ahead and I'm going to say, well, I'm going to undo that subtracting 4a by adding 4a. Okay, so that gives me 3 equals 9a minus 15, right? 5a plus 4a is 9a. Over here, subtracting 4a and adding 4a canceled each other out. So now it's just a two-step equation. I'm going to add 15 to both sides. So I get 18 equals 9 times a, and then I'm going to divide both sides by 9, which gives me 2 equals a. Okay, and if I wanted to, I could go ahead and plug them back in and check to see if it makes sense. 3 minus, what's 4 times 2? 8. 3 minus 8 is negative 5. Okay, and then over here, what's 2 minus 3? Negative 1. 5 times negative 1 is negative 5. So when I plugged 2 in, I made an equation that said negative 5 equals negative 5, which is true. Okay, so here we go. Down here for letter, oops, there you go. Letter D. I'm going to do my distributive property, okay? So I'm going to leave everything on the left alone. 8y minus 6 equals 2/3 of 6. 2 times 6 is 12. 12 divided by 3 is 4y. 2 times 15 is 30. 30 divided by 3, oops, sorry, 2 times 15 is 30. 30 divided by 3 is 10. I thought I messed up, but I didn't. Okay, I only want variables on one side. Subtract 4y from both. So that gives me 4y minus 6 equals 10. Now we're going to add 6 to both sides. So I get 4y is 16. Divide both sides by 4 to get y equals 4. Letter E. So there's distributive property on the right. So 3x equals 3 times x is 3x plus 3 times 4 is 12. Okay, look at what's happening here. I have 3 times a number is the same as 3 times a number plus 12. Does that even make sense? What's happening? Is there some number that I can plug in here to make it true? No, right? This answer is going to be no solution, okay? And I'll show you, you could take it even further, right? I only want variables on one side. Take away 3x, take away 3x. 3x minus 3x is 0. These cancel out because that's 0. Does 0 equal 12? No. So this answer is no solution. Okay, there is no solution to this equation because there's nothing you can plug in there to make it true. Okay, so if you end up with something that's not a true statement, right? 0 does not equal 12. We eliminated all of the variables and it wasn't true. Then it's no solution. And then letter F, let's look at this one. So I'm going to leave the left-hand side alone, and I'm going to come over here. 2 times x is 2x, plus 2 times 5 is 10. Okay, so this one is different because these two sides are identical, right? I could put anything in here for x, and it's going to be true. You could put in -4, because if I put it into both sides are the same. so it's going to be true. I could put in a million. 2,010,000 equals 2,010,000. You could put in 7/8, right? It's going to give you the exact same thing on both sides. So this, we write all real numbers. Okay, I know some of y'all are like, well, can I write ARN or all reals or something? No, you have to write out all real numbers. Okay, we could take it one step further, right, where I have 2x plus 10 equals 2x plus 10. So it should be obvious, right? It's identical on both sides. Let's say it wasn't, and you're like, okay, well, I'm going to get rid of my x's from both sides, okay, or from the right-hand side. Well, it's going to cross them off over here. So we get 10 equals 10. Is that a true statement? Yeah. So that should tell you that it's going to be all real numbers.